Till now, we have been using the Python shell directly so far. So we have defined a class called dog yesterday, last time. So this time I'm going to use text editors and then execute the Python scripts from the shell. So I'm not going to use the Python shell directly. Let's go back to where we left off last time. So we are seeing data types. The last topic that we discussed was the classes and inheritance. Let me go. Okay. So this time I'm going to repeat what we discussed in the class inheritance. Let me create a new file, main.py. So here, last time we have declared a class called dog, and this was a parent class. We didn't have any superclass for this, and we had defined another small dog class. But before that, I'm going to explain this one more time so that it's clear. So dog class, I'm going to declare a class attribute called legs. So usually how we define class attributes is directly under the class. And if I define something like init, so this is actually called the constructor. Init is called a constructor. This is a method inside a class. So inside the class, if I write any function, it's called a method. So here, if I declare a variable with name, this will become an instance variable. So this means any instance of a dog will have its own copy of this name, whereas this variable is at the class level rather than at the instance level, because all dogs will have 4 legs. That's a default property of a dog. So each dog might have a different name. That is why we have defined it as an instance variable. Let's write something, and if I have to configure this, if I have to accept it as a parameter and use a dynamic name, so I need to also accept a parameter or argument for this constructor method. So whatever I use here as arguments, those things need to be passed while constructing an instance of this object. Let's say I'll use the name here. So when I'm actually creating a dog object, so dog equals dog, the name parameter has to be passed from here, Rex. So I can actually name it like name equals Rex. This is also allowed. We can explicitly mention which argument are we passing. And if it is not named, it depends on the order we pass. Let's say I have another thing called age. I can say like another parameter like this. So this depends on the order. So if I'm not using the named parameter format, it depends on the order that we are passing. If I'm not using this order, I can just use age as 5, name as Rex. This is perfectly valid. If I'm not using the named parameters, I need to pass them in order. Age as 5. So sub.age, age. So I have also defined a method called speak, and with this, every method in an instance will accept default first parameter as self. Self means this instance of the object. It refers to itself. So self. So we also have discussed the F strings. I'm going to use an F string here. By default, I can use single quotes or double quotes. If I'm using single quotes, when I'm typing down inside here, if I have to use double quotes, I can use it directly. If I'm using double quotes, if I type it down here, I cannot use double quotes inside it. If I have to use double quotes, I have to escape these quotes with backslash character, like this. Similarly, if I'm using single quotes, if I have to use double quotes in the middle, I can perfectly use it. If I have to use single quotes again, I still have to escape these. So as you can see, this color is different because the string starts here, ends here. If I am using the single quote, starts here, ends here. So if I have to escape, this is how I need to include these quotes inside the another string, another quoted string. So I'm going to use F strings. The advantage with F strings is I can actually use any expression, any Python expression within this F string, within this opening and closing brackets. Self dot name says 5. So this gets replaced by this particular name. Okay. Now, if I do dom.speak, I've written simple code, simple Python file here. So how do I execute this file? Is I should call Python and with the file name main.py. So it executes. These are the lines that it executed. So if I just keep this declaration and don't have these commented out, let's have these commented out. Even when I execute something like Python main.py, it doesn't do anything. We are just declaring a class and implementation details I'm giving. So I'm not initializing that object or executing anything. So this still is executed, but actually it doesn't have anything to print because we haven't instantiated any object of dog type and we haven't called any method on it. So this calls the constructor. So when I'm passing two arguments, this calls the constructor. Okay. So this part is clear, right? When we are instantiating, we are actually calling the constructor method. This init is called the constructor. So we have initially instantiated, and that's about declaring a class or an object. So this is a class, and an instance of a class is called the object. Dog is now an object. Okay. Last time we have already also seen the inheritance mechanism. Let's demonstrate that one more time now. So I'm going to create a small dog that extends the functionality of the dog. So how do I declare it? It's like this. If I'm putting this, any object or any class inside the parenthesis of another class, this class inherits from the one that is passed in the brackets. So without having any implementation details, I can inherit all these properties on the small dog. So I'll just create an instance of small dog. Say I will just say Lipson. It's 2 years old. Just going to call the same method. It can be anything, but my ESLint is showing some weird messages. That's why I renamed it. So you can use any variable name. That's no problem. So let me execute the script again. This is a Spark. So small dog inherited all the methods and constructors from the parent class, which is dog. If I add one more, let's say if I want to print age, self dot age, I am self dot age years old. So this depends on the implementation. So this, I'm just initializing the attribute, but I'm not printing it when I'm doing a speak call. So now it will print. If I do that one more time, I'm doing this now. Okay, if I have to extend this functionality, instead of putting it here, let's just remove this from here to demonstrate the inheritance mechanism. So I don't have the implementation of printing the age in the parent class. So I can override this functionality in this subclass. This is called a subclass or a child class. This is the parent class. And I'm going to re-implement this functionality and have that do something else. So instead of printing like this, I'll just print I am self.age years old. Print I cannot park. Now, when I call small dogs or speed, it doesn't call this function, but it actually calls this function because this object is an instance of small dog. So I did one thing last. Let's remove this and let's put a pass here. I don't have implemented this. It's commented out. Even when I do small dog execution, this gets called. So same implementation. Fine. Now I'll have a custom implementation which does also print the age, the small dog. Let's do that now. So I'm 2 years old, I cannot bark. So instead of this, if I just call this dog, it doesn't print this because it is an object of dog type, not small dog type. Let's say Spark. Okay. So I'll just uncomment both these lines and execute now. Rex says Spark, and this says I'm 2 years old. Let me put the prefix self.name here. Okay, clear. Rex says Spark. Lucy says I'm 2 years old. Lucy says I cannot bark. So when we have the same method implemented, it overrides the previous parent class's method. Let's say I have another method implemented. Let's say print my what's your age. This line, I'm going to move it outside of here and put it under this. And it's called small dog. Storage. Let me execute. Lisa says I'm 2 years old. Okay, if I do the same thing on dog object, let's see. Dog dot what's your name? dog object has no attribute, what's your age? Because this class doesn't have that implementation. So when I'm inheriting a superclass, this is called the superclass or a parent class. This is a subclass or a child class. So when I'm inheriting from a class, this gets all the attributes, all the methods from the parent class. Whatever custom implementations I can do on the child class, I can do it. So the whatever implementation we did in child class will not propagate back to the parent class. So it's only up to this. Let's just create one more class called tiny dog, which extends small dog. This tiny dog will inherit from small dog. Small dog will inherit from dog. So let's say I will instantiate a new object called tiny dog. Instantiate tiny dog. Tiny. Tiny dog speak. I should comment out this because it will error out if there is any error. Okay. Text says bark. Lucy says I cannot bark. I'm 2 years old. Tiny says I cannot bark and I'm on a year old. What's happening here is tiny dog is inheriting from small dog. So all the properties of, we haven't declared age or name or even legs in any of these subclasses. Legs is getting inherited from dogs. Name, age is getting inherited from dog class. And speak is inherited from small dog for tiny dog. So this is how inheritance works. It's like down the hierarchy. The children will get all the properties of the parents. Whatever the children has implementation details, it will not propagate back to the parent class. Okay, this is a simple implementation of class hierarchy. Let's have custom data types. Let's say I want to inherit from a parent class, which is actually a built-in class. So if you see Python, if you go into Python, if you do type of int, it is actually a class. If I say a equals 5, type of 5, it's actually a class int. So if I want to extend existing built-in types, let's go try list, a as a list. Type of a is the class called list. I can actually extend this list functionality within my own custom list function, custom list. Let's say I'll implement a unique list functionality. So I will extend from built-in data type called list. List itself is a class. I can extend from list. So if I want to implement something like a set unique list, I can declare it and I can inherit all the properties of a list by putting the list as the parent class for this. Now if I do unique list, let's print unique list. It's the same thing. So now I'm going to override the functionality to append the new elements. Let's say definition of append. So we have already seen that list objects have append function. A dot append of 3. And if I print A, it actually appends the item to it. If I do one more time append, it will add a duplicate. So now with the unique list, I'm going to eliminate this duplicate. This functionality is already available with sets data types, but I'm going to repeat that with extending the class. I'm just trying to re-implement the same set functionality with my own custom class. So let's do a define of append function item. If actually this has to accept self as a parameter. If self, okay. There is one concept we need to introduce here. Before actually initializing this, all the previous functionality of list also has to be initialized. So I'm going to override the constructor here. So it also should call the previous list's initializations. List, when I'm instantiating a list, it does recalculate some attributes and stores them in memory. So that functionality, if I have to get it inherited, and whenever I construct a unique list object, that also has to get called. So how do I call the parent class's constructor is like this. Super will give us the parent class's function, parent class, and then I can call the same constructor on the parent class like this. So when I'm constructing a unique list object, I also need to have the same functionality of the parent class, which is the list. So I need to do that through this way. If I don't override this, by default, the constructor comes from the list itself. This is perfectly okay not to extend or override the initialization. Let's do this way. We will override the constructor in a little bit more detailed fashion. For now, let's just override append functionality. It accepts a self as a default argument, and I need to add an item to it. So I need to check if the item is already existing in the current list or not. If item in self current. Self actually refers to the current object. So what we have seen in the list is that this is a membership operator, and this membership operator works on the list. List is an iterable data type, so membership operators will work on the list objects. Self actually is the type, is of type list. Let's just try to do something like this. If I just print type of list or type of self, it is going to print list. So actually it's going to print unique list. Let's just call that function unique list dot append. I'm just going to pass one random thing, but it doesn't do anything. Let's try it. So this actually printed the type of the self as unique list. So, but all the properties of a list will be propagated from the parent class. That's why I can actually use in membership operator. If item in self, this means it checks if the item is already there in my list of objects. Return, just don't do anything, don't add anything. Otherwise, super dot append item. If it is there, don't add it. If it is not there, call the super. Super means the parent class lists append with the same item. But if the item was there, add it. If not, do the default functionality that the parent class gives. So now if I do here, it's printed. If I add one more time, the same thing, 3, 4, let's see, better. Now if I execute this, and it only gives the unique values. When I appended one more key, it did not add it to the list, but only return from it. So this is one way to override constraint. Now let's override an extra parameter. Let's say add some extra argument or attribute to this particular instance. So how do I do that? Is through overriding constructor. Something like a message. I'm going to add some simple message to it. Self dot. So when I'm overriding the constructor of a default data type, I need the data types functionality also. So same thing has to be called from the initialization. Otherwise, we will miss one of the functionality or initializations that happen by default by the built-in data types. So this is how we call superclasses constructor. Now let's say with this message I'm going to have another property and then list self dot message. If I do the same thing, let's print start message. Actually, we should pass a message to this. So if I'm overriding this, the message also needs to be passed. Message some custom message. Okay, now it's printed. We have extended the functionality of list, and we have made it as unique, and then also added a extra attribute that the list doesn't do by default. This is how we override built-in data types also. So let's see another example of parent and child classes. So let's say I will have a class called shapes, or file called shapes. So I'll create a class called shape, which does have some property called width. I'll initialize to 5, height 5, print character. So it's just a character that I use to print on the console, and I'll show you where I use it. So let's say I have one function print for self comma I, which means it prints items. Let's do a pass here. Later we will implement that. So if I want to print this shape, it's just do I right print. So I'll implement this and then explore how this works. So this one, let's just print something. This actually prints a particular line. If I'm drawing a square or a triangle, it prints one line on the console. So this functionality has to be implemented by, let's say I have a class called square that extends shape. The print row functionality has to be implemented by this guy, this particular class, subclass. Similarly, if I'm implementing class called triangle, that also extends from shape, has width and height, and it has to extend the functionality for print width. The common thing here is every shape should implement its own print functionality, print row functionality. So it can share all the print functionality can be shared across all shapes. For each row, it's going to call print row function. So this print row method is not implemented in shape class. So if somebody tries to call this shapes print row, we need to raise something called an exception. I'll go in depth into exceptions in a bit. Not implemented. Can you implement it? It's not class, but so if I try to access print row functionality, let's try to instantiate an object called shape. By default, the width and height will be set to 5. Let's try. That's it's called shape. Close measure. Shapes. Because it will be implemented in the child class. Because this is not implemented, and we are raising this particular method whenever somebody tries to call it on the base class or the parent class. So now let's implement the same functionality in the print row, how to print the row in a square. So for each of the rows, let's say height is 5 square foot or 5 inches. For each inch, it has to print one line. Let's do that. So the functionality of printing, calling the print row functionality is already here. We just need to override this. So I will just print self dot print character into which one is sorry, not to be self dot width. So square means it's even. So remember, if I do phone number, it will create a square triangle. Let's do this and create an object called square. Square dot then. Let's try printing that. It has created a square. Okay. Then 5 characters on 5 rows down. So this actually is like a rectangle, but it's considered as 5 into 5. That is what it has printed. For each line, it's printed 5 characters. So let's implement the same thing in triangle. How do we print a triangle here? Is for every row and character into 9 plus 1. Will it give us for the first row 0 actually means, so it starts from 0, right? Every time. So first row should have one character printed. Second row should have 2 characters and so on. Let's try doing that. Let's triangle. So first thing we printed a square, and then second time we printed a triangle. So what if I want to print this triangle not as a right angle triangle and a symmetric one? Let's say like this. Like this. Let's do that. Symmetric triangle. Let's implement a new triangle class. Symmetric. That extends from triangle. Print row, I'm going to override the print row. I'm just going to override height and width also. Because height is fine. And width should be 2 because see, if I have to leave spaces, if the width is 5, if it is 1, and the first 2 spaces and right 2 spaces I should leave and put only here. So the character only here. The total width will become 2 times the length of it, 2 times the height of it. Sorry. Width it becomes 2 times the height. So for this, print for each row, we have to calculate triangle width. It will be 2 times the row. First row means I have to leave 2 spaces in the front and 2 spaces in the back. That's why it will become the number 2 plus 1. Because I starts from 0, that's why we need to add. Adding I need to count width of it. Whole thing. And this will give us the height, which is the front, how many we should leave, behind how many we should leave. That is just the right to say. I'll explain the logic. So now I have to first print the spaces into the padding length, and then print the character of the triangle. Symmetric. And let's try printing this. Okay. Now, the first row has actually occupied this much, which means 1, 2, 3, 4, 5, 6, 7, 9. This many characters, 9, and there is 1 actually left on the right. Just 1 space is left on the right. This is actually 10 characters in here. first row and the last row prints 9 characters. The next one 7 and then 5 and then 3 and then 1. So this is like this pattern and how to print these characters. This calculation we have done based on the total length of characters and then what is the padding we found out, and in the middle we have to print the character that we had. I have to print 3, so I need to leave behind 3 characters and then 3 characters for that in order to align. That's what this calculation is all about. It's just a simple example. This calculation need not be learn on your own based on what type of formatting we can actually print fields or something. There are libraries that allow us to print these type of patterns. We'll go into that in a second. So it's about just to demonstrate the extendability of the functionality of whichever class. Next concept, we have to look into something called exceptions. Let's say I divide by 0, something like 1 by 0. Let's try telling that. And Python is giving an error called 0 division error. So we can't actually compute 1 divided by 0 because 1 divided by 0 is an infinite number. And computers cannot calculate these large numbers. I mean, infinite numbers, it cannot. So it throws an error whenever we try to do invalid calculations. So in our code, if we have to handle this kind of errors, let's see how this works. I'm defining a function that does this, and then I did plainly in one line, and it gave me this error. Let's call this function. There is something called stack trace in Python. I will demonstrate that. So this has given 2 lines here. So earlier it gave me one instance where it failed. And here trace back it has given me. So we are called 1 divided by 0 and so on so on. And that is actually called from this function and so on so on. So this is called the stack trace of an array. Let's add one more. So as we add more elements to it, stack trace increases. We should call errors. If I have methods calling functions calling another function and another function calling another function, and wherever the issue happened, it will print the entire stack trace of which method called which method and where exactly the error occurred. So if we have to gracefully handle these errors, we need to put these in try catch blocks. So there is something called let's remove this. I'm just going to remove this also. There's something called try, and then do something here. And there's something called catch. So every try has to have its own catch. So cannot catch except. And let's just try 1 divided by 0 here. If I do it this way, let's see, division by 0. So actually the error has been raised. If I don't handle this, it prints it like this. This is kind of a crashing of the script. Yeah, entire execution halts, and then you won't have any way to resume the program. So if I gracefully handle it in exceptions like this, I can actually have some code written here or some code here. Let's say I'll just print here. And just as soon as this gets executed, this the entire program after this will not get executed. If I run it now, the statement did not get executed. We'll just comment out this part. Even though we are having the problem here, we are actually handling this in the except block and gracefully continuing the program. Let's do that now. Here. So division by 0, it has printed the error and it continued execution. In our server programs, every time we encounter an issue, it should not crash the server, it should continue execution and continue with the other requests. So that is where our try except blocks help. So if I just try to see what's the type of this exception, let's print it. This is actually a 0 division error. Let's say now, as I'm using the exception class here, what is the exception we are unable to get? If I don't need that information, I can actually eliminate this part as E. I can remove just trying to print some error. If I'm not interested in what the error is, I can actually remove that E. And that is one way to handle specific type of errors. So we have this is exception is the parent class of all exceptions. So there is a specific type called 0 division error that is being thrown when we are executing this statement. So I can actually handle that error here and in the order that they are handled is important. Font 0 division error. And if I do execute this block got executed because it's matching the error that we are getting. So if I do this changing the order, if I change the order, so order actually matters. If a generic exception is handled first, only always this matches this exception. Because 0 division error is a subclass of exception, and if except block has a generic type in the first, it always goes into that block and everything else will get ignored. So while handling exceptions, you should always handle the more specific one first and then the more generalized one in the end. So let's say if I have some other exception introduced, I'm trying to add one and which is a type error. Let's try executing this. So let's remove this one layer by 0. Some error occur. I don't know which error. Let's try getting the error type. I'll just print that's the error type. This is the message that we got. Actually, I'm interested in the type of this error. This is called the type error. So if I now handle accept type error, then type error. this gets matched first before this type error. So different types of exceptions can be handled like this. The exceptions are a way to gracefully handle program execution if some error happens. And there is actually one better way to do this. Let's put this in a function. Let's say cause error. Let's just put this in a function and call this cause error from let's just I'll put it in separate block. Just comment out this tag so that it's useful as a reference. I'm going to implement this function cause error that does from a and cause error. So we have also seen decorators. We just had an introduction to decorators, but we haven't seen how the decorators are implemented. If I have to handle this entire thing in every function that I implement, that becomes more and more difficult. So that's why we are going to use decorators, implement our own decorator and use decorator. We have seen decorators something like this handle exception. And this decorator has not been implemented yet. So we're going to implement this handle exceptions decorator now. So for this, I'm going to implement a function called handle exceptions that accepts a function parameter and then implement a wrapper function here. Wrapper try function in this entire block of exception handling. I'm going to put inside here. What this is going to do is, so at the end, I'm going to return the wrapper function. So this is actually a decorator, a function that calls another function that accepts a function as an argument, as we have seen earlier. Functions also can be stored into variables. Say handle exception. Also, this also can be used. This way also we can A now refers to handle function exceptions. Function. That's how we are actually, whenever we are declaring handle exceptions, this entire function is getting passed as an argument to this decorator. Whenever we are declaring this decorator, that means we're actually passing this entire function as an argument to this decorator function. So what I have done, I have declared another wrapper function inside it that calls this particular function and handles it. And the wrapper function I'm returning from the decorator function. So this is how we implement a decorator. Let's try running this code. Now I'm calling cause error, which is wrapped under a decorator. By default, it handles all the exceptions that we have discussed so far. Let's try exceptions. Type in a vector because we haven't done any handling of exceptions in this particular function, but we have handled it inside this decorator. What if I have arguments here? Cause error 9. Let's say I will implement the function that only accepts integers. So I have character. This if n character is n argument is a letter, let's just use n here. Cause error of a is integrable. Multiple times I'm going to close it. One time I'll use an integer, one time I'll use a float. And so on. So whenever exception occurs, this has to get executed, just decorate it. But we're not actually passing any argument. Let's try and run this as it is. And cause error, handle exception takes 0 position of ones, but 1 was given. But basically, this is not accepting any arguments. We have to accept arguments in order to make it work for all the functions which have any number of arguments. So for that, I'm going to use arms here. Same thing I'm going to use here. Pass this functions. So now, when I'm wrapping this function inside a decorator, all the arguments that I'm passing is going to get passed to this as args parameter. Let's try running that. And this works. Type of third. Set type error. Let's just come into these last words. It's passing actually a list. So we should unwrap the list with star parts, which will unwrap all the list of items. How it works. Let's try with A. Let's print actually the result. So when I passed 1, it printed. So it has handled the exception. I am passing 3. So it did not halt the program. It did execute. Gracefully handled all these. So 2 is returning to because always the non-zero number is always going to result in 2. And 2 actually the value of 2 is wrapped as 1. So if I can show you, and if I wrap this integer, it returns 1. 2 is considered as value 1 when I'm having 1 plus 2. Because 2 choose value will be 1. So that's about handling exceptions and decorators to use functionality. And similar to this, I can actually have custom exceptions. Let me implement on the class called custom exception. This has to extend from default exception class, which is provided by. But just define a class called cause error. Inside here, I'm going to phrase the exception called custom exception. Let's call it cause error. Let's see what this is. Okay, it has printed custom exception with the factors, that's fine, but it doesn't give me any information what the error is all about. So if I have to print something here, I need to pass some message on the exception. This is custom Let's execute that. Yeah. And custom exception. Now it's giving that message for the class. Let's implement something similar in a more detailed fashion. Let's say I have a HTTP exception. Whenever a web server is having difficulty or having issues, it's going to throw an error that is a subclass of HTTP exception. So by default, gives a inherits from exception. I will have one property or attribute inside this status code minus initialize to the message ID as one for one as this is a pair class. Let's initialize this with a constructor that calls parent classes constructor, all the functionality I need. Whenever keep in note that whenever we are extending a default base implementation of any built-in types, we need to call the superclasses constructor whenever we are overriding the constructor. If you're not overriding this, by default, whenever you instantiate this object, it automatically calls previous superclasses constructor. If you are overriding it, it won't. So when we are overriding it, if we want to have the parent class's functionality, we have to call the parent class in the constructor like this. In the same thing, this accepts string as a message. Self.status code status code this message this message. Now we have overridden the constructor. Let's extend this functionality with 404 not found error. Not found error with some page is accessed and we don't have that page in the website. We can I'm going to extend HTTP exception as a parent class. And I'm going to use status code as 404. That's the status code for HTTP not found. The message was the source not found. Now, on this one, we don't need to extend constructor. By default, it's inherited from the parent class HTTP exception. Let's say another error, server error. That extends the same HTTP exception. So usually status code will find it for internal server errors and message I can put in server. Let's create a function, trace server error. Trace server error. We don't need to override anything, message or anything. I can just trace server error like this. External custom exceptions. Status code of this one. Yeah, this has thrown an error. Exception called server error. Status code which printed from this because we are initialized and extended it from exception class. That's how we extend classes. And next topic we have to discuss about is multi-threading and multi-processing. So far we have been executing these code one by one. So if I have to, let's say, just add one. I have, let's say, I will create a definition of function long square. Yeah. That returns n square. But when calculating this, I'm going to sleep for 2 seconds. Time was at 2 seconds. This is just to simulate a long process. Just bottom down margin from default library. Let's say I will execute the list current. Long square of n, but n in range 0, 10. This actually prints all squares of 0 till 10. Each of them will take like 2 seconds. Let's try running this. Instead of waiting like this, let's just print. So, calculator. Every 2 seconds, it will calculate 1 line for 0. 1. So, okay, this is a simulation of the functionality of a long process. Let's say some function executes does so many calculations, and we want that function executed every time. For every large number of times, if we have to call that. So waiting for that is not a good idea. So far we have been executing or calculating these things one at a time. So what if we want to accelerate this process, and the processor is much more powerful than one single calculation. It can do multiple calculations at once. So this really still just make use of this powerful CPU. We can have multiple threads running. Each thread actually needs a parallelization mechanism for us to execute multiple calculations at once. So if this long square process or a function needs to be executed multiple times for multiple different values, we can make use of multi-threading. So we can parallelly trigger this function calculation for multiple values at once. So in this particular case, we are actually calling this function for every value and in sequential order. We are not parallelly triggering the calculation mechanism and then collecting the things. No. We're actually calling this every time. Once the first 0 value is calculated, square of 0 is calculated, we are again calling for 1 and then for 2 and then for 3. So the use case of multi-threading, we can call this function for 1, 2, 3, all in parallel. Let's see that tomorrow. Multi-threading, if we discuss now, it will be too much confusing. Let's see how this multi-threading works.